Hello everyone. In this video, we're going to talk about the difference quotient. Now, the difference quotient is a very important topic in calculus. It's one of the foundational pieces, and we're going to be using it a lot. But here I just want to take a look at the basics of it, and we'll use the difference quotient in a couple examples. So on the screen, I laid out what the difference quotient does. I said the difference quotient is used to calculate the slope of the secant line between 2 points on the graph of a function f. Okay, so there's a lot going on in there. So the slope of a line, we know what that represents. Back from algebra and geometry, we remember that the slope formula, slope is equal to the difference of our y values divided by the difference of our x values. Okay. Now the other piece that's important on here is the secant line. So if you remember back, the secant line, all this is, it's a line that connects 2 points, usually on a curve. So let me get a graph to show you what this looks like. And in calculus, a lot of the time we are going to be dealing with curves. So this idea is really important. Now, when we found slope in the past, using our slope formula, we used just regular lines. Okay, but now that we're dealing with a curve, it's not as easy to find the slope for the entire thing. So that's where the difference quotient comes in. So let's say we have 2 points somewhere on this curve. Let's put one right here, and it doesn't matter, let's put another one right here. So the secant line is going to be the one that goes in between these two. All right, so this line connecting these 2 points we put on our curve, that is the secant line. Now let's use our slope formula, and let's use our function notation, since that's what we're talking about, to find the slope of this. So for this first one, let's say that this has an x value. We don't know what this is. We want to keep it general. So let's just say that this is x. Now that means the y value, because our function is defined as named as f, this y value is f of x. So this point is x and f of x. Okay, now for our second one, we also don't know where that point is. It looks like the x value is about here, but just to keep things a little bit simpler, I don't want to introduce a completely new variable. I want this to be related to my first point. So I already know that from 0 to get to here, I have a value of x, or change of x. Now to get from x to my second point, let's say that the change in between these, let's say this has a change of h, just another variable. So that means that this x value is x plus that change there. So this is x plus h. And now that I've identified that, I know that the y value that matches up with this is going to be whatever my function is of x plus h. So then this point, we have coordinates x plus h, and then f of x plus h. And now using those 2 points, we can plug them into our slope formula, and we'll end up with something that represents our difference quotient. So we'll start with the further point here. So my 2 y values, we have f of x plus h minus the first one here, f of x. And then this is going to be divided by our difference in x values. So our farthest x value is x plus h, and then we'll subtract our first one, which is just x. And we can actually do a little simplifying. So in the denominator, we have x, and we have a negative x. So our difference quotient is defined by the expression f of x plus h minus f of x and divided by h. And now this allows us to find the slope of a secant line on a curve. Now in calculus, eventually what we're going to do is we're going to take our second point, the one that is h away, we're going to move this closer and closer and closer and closer to our first point until that the distance between them is practically zero. But we'll save that for another time. Let's use our difference quotient in an example. Okay, so first one, f of x is equal to 2x squared minus 3x. I want to find the difference quotient. So I'm going to find an expression that would allow me to find the slope. So I like to do this in a couple pieces. First, I'm going to find f of x plus h. I find it's just easier to organize my work this way. So evaluating function again, we're just going to take x plus h and we'll plug it in. And then minus, and then instead of x, we have x plus h. And then right away, let's simplify this as much as we can. So again, this is a binomial squared. After a little bit of time, you're going to get really used to this. So it follows a pattern, x squared, in the middle, x times h, and then there's two of those, and then h squared. Minus 3 times x plus h. All right, and then we can distribute. So we end up with 2x squared plus 4xh plus 2h squared. And then our second term here, distributing the negative 3, we have minus 3x and minus 3h. Okay, so now that I've figured that out, now we can plug everything into our difference quotient. So if I flip back here, my difference quotient is the expression for f of x plus h. We'll subtract the expression for f of x, which is what we started with, so we already know that, and then we'll divide by h. So for the first one, my difference quotient, I think I'm going to need a little more room. So f of x plus h, we have 2x squared plus 4xh, it's that entire expression, plus 2h squared, and then minus 3x minus 3h. And then from that, we're going to subtract the entire original function we were given. So minus 2x squared minus 3x. And I am putting that in parentheses because I do want to subtract that whole thing, meaning we are going to need to distribute that negative. And this is all divided by a lonely h. All right, let's combine some like terms, see what we end up with. So we have a 2x squared, and then we'll minus a 2x squared there, so those cancel out. We have a minus 3x, and then this is going to be actually a plus 3x. So these also cancel out. So what we're left with then in the numerator is we have a 4xh plus 2h squared and a minus 3h. Still divided by h. And the last piece, if I look in the numerator, each one of these terms has an h in them, so we can divide that out. In our difference quotient, what we end up with, so the h cancels out, we have 4x plus 2h, one of those h's cancels out, minus 3. So there's our difference quotient. We had to do a little bit of work to get there, but now we have this nice easy expression that would allow us to calculate the slope for any secant line that is on this graph. And let's just do one more. A little bit simpler this one. G of x is equal to the square root of x. So first thing, let's find g of x plus h. So replacing x with x plus h, we have the square root of x. And now for our difference quotient. So first we have our g of x plus h. So x plus h and the square root. And then we'll subtract our original function. And this is all over h. Okay, now to handle this one, doesn't look like we can simplify anything right off the bat, but we can rationalize the numerator. So to do that, I'm going to use a conjugate. With the conjugate, I know that our middle terms cancel out, so that's going to help us out here. So I'm going to multiply numerator and denominator by the conjugate, so the square root of x plus h, and then instead of minus, it'll be plus the square root of x. And since we did that to the numerator, we have to do that to the denominator as well. Okay. Now, numerator and denominator act as grouping symbols. So when I multiply these together, since one is positive and one is negative in the middle, that middle term cancels out. And all we're left with then is x plus h, the square root goes away, and then minus x. And in the denominator, now it's h times all of this stuff. So we have h times our square roots. Okay, almost there. Looking at the numerator, we have a positive x and a negative x. So those result in 0, and we just have h. Our denominator stays the same. And then, as we can see, we're only left with an h in the numerator, and we have an h in the denominator, so those will simplify. So lastly, our difference quotient is 1 over these two square roots. So the square root of x plus h plus the square root of x. So thanks for watching. The difference quotient will be coming back. We're going to use it quite a bit. So hopefully this little intro made sense. Thanks.